चलो पीरियड सी की क्वेश्चंस, ठीक है, वही वर्कशीट है। उसमें वो कह रहे हैं कि क्लोरीन इज वेरी रिएक्टिव एंड विल फॉर्म कंपाउंड्स बाय डायरेक्ट कॉम्बिनेशन विद मेनी elements. ठीक है, describe what you would see when chlorine is passed over separate heated samples of sodium. Now this is what you are going to see. तो पहला तो है कि सोडियम जो है क्या होगा, if it reacts with chlorine, what's going to happen? It's going to form NaCl. तो anyways, बताना ये कि what you would see. तो वैसे तो क्या लगा, what would you see when this happens? What would be the observation? What type of compound is NaCl? मतलब कलर, क्या कलर है उसका? NaCl. Mine, what's the color?
White.
ठीक है, and it's going to be a white solid. ठीक है. So one observation is that a white solid forms. The other one is okay, when chlorine reacts, so it's going to get used up. So what's the color of chlorine? Chlorine is greenish yellow. So the greenish yellow gas would disappear. Because it will end up reacting with. So it disappears. फिर इसी तरह he's asking about phosphorus reacting with Cl2 and he's asking क्या उससे कहा था, in each case write an equation. So the observation is just for 1 mark. 1 mark for equation, and it has to always remember it has to be a balanced equation. As a phosphorus reacts with chlorine, it would form two things. It will either form PCl3 or it can also form PCl5. Let's go with PCl3. So 3, this would be 2, and this would be 2. Phosphorus is a solid. ठीक है, कलर्स पता होने चाहिए सारी चीजों के. Phosphorus is यहाँ पे लिखा है, नहीं लिखा हुआ. Make sure you know what things look like. और इसमें दो थे, white था और red था, बल्कि we did that in the last class. There's red phosphorus and there's white phosphorus. Red phosphorus is usually the polymeric form. So actually उसके काफी ज़्यादा forms हैं. White one is this one, red phosphorus. तो इनके colors याद रखने. अच्छा, so the first thing is in this one, इसके अंदर भी वही होगा. What will happen is that the greenish yellow gas disappears. Yellow gas, it is disappearing or becomes decolorized. अच्छा, what does PCl3 or PCl5 look like? PCl3 is probably a colorless liquid. ठीक है, जो कि यहाँ पे hopefully would be given over here. यहाँ पे mentioned है. ठीक है, make sure. So PCl3 is a colorless liquid and PCl5 is an unstable white solid. So a colorless liquid is going to be formed, which is going to be of PCl3. But anyways, for this question, you didn't actually have to go into that much detail. What you just needed to know was it was a very simple question. 1 mark for equation, 1 mark for this equation. The rest of the 1 mark was for observation, which was pretty straightforward. Okay, if you have NaCl, you know that it's a white solid, and if you have Cl2 gas, it's getting used up. You should know that it's a greenish yellow gas, and it will disappear because it will get used up. You don't really need to go into that much detail about what phosphorus looks like, so what PCl3 looks like. For the sake of revision, but you don't need that much detail. So the next one is magnesium chloride and silicon chloride is dissolved in water. Suggest the approximate pH. So again, this is about hydrolysis. Hydrolysis, this one has very slight hydrolysis. So the pH is just 6.5. And this one is stronger hydrolysis. The pH is around 2. That's given in the notes. TK, we did discuss this. What happens when you react a chloride with water? NaCl only dissolves. That's the only thing that happens. And it dissociates into its ions. MgCl2, it's got a much bigger positive charge. So since it's got a much bigger positive charge, it ionizes the water molecules and turns it into MgOH2 and releases H plus ions, but very slight hydrolysis. And as you go down the group, the hydrolysis becomes stronger and stronger. SI case where the hydrolysis is pretty strong. It's a strongly acidic solution that is going to be formed. So explain with the aid of an equation. So all you have to do is, iska batana it mostly dissolves. So what is the equation for something dissolving? That's MgCl2 solid. You mix it in water, aqueous, and it will turn or dissociate into aqueous ions. And the other one is, iska yoga ke most, it's usually it's strong hydrolysis, vigorous reaction. And you can write the equation SiCl4 reacting with water, it would form SiO2 or SiOH4, plus it will give off HCl. Make sure the equations are balanced, okay? So you clear, remember this, what happens to each of the chlorides when you add them in water across the period, the hydrolysis becomes stronger and stronger. Clear? Munib Hamza.
Yes, sir.
That's the next one. The elements that react with, tell the formula. The formula is phosphorus is P4, sulfur is S8, and chlorine is diatomic HCl2. Okay? The structures of each one of them is drawn as well. यहाँ पे लिखा हुआ है. ठीक है? So chlorine exists as a Cl2 molecule. Phosphorus is a P4 molecule, which can actually form a polymer as well. Sulfur is S8, and argon is a monatomic gas. Place the three elements in order of the highest. So Van der Waals forces, S8 will have the highest because it's the biggest molecule, followed by P4, and then followed by Cl2. So you got to remember this graph. Okay? Sulfur, phosphorus, and then chlorine. The next thing is explanation for the order. Explanation is bigger molecules have more Van der Waals forces. Bigger molecules have more electrons. Hence, they have more Van der Waals. So more energy is needed to, but more energy is needed to break them. Which is why their boiling points are higher. You've got this question. It says that give the equation with state symbol for the reaction of phosphorus with chlorine to form. So, I mean, just this thing PCl5, you can balance this. And suggest in terms of structure and bonding explanation for the following. You should draw diagrams where you think they will help your answer. The high melting, so this is ionic. It's an ionic compound. So why do ionic compounds have high melting points? Because you can draw the structure. It's got a giant ionic lattice. You've got a bunch of positive ions, you've got a bunch of negative ions, and they're all strongly attracted to each other. They're all strongly attracted to each other. So it's a giant structure which endlessly repeats. So the first thing is it's got lots of ionic bonds, giant ionic lattice. And there's a strong electrostatic attraction between positive ions and negative ions. And the low melting point of silicon tetrachloride, that's a covalent molecule. plus it's non-polar as well. So this one is a covalent molecule. What happens in covalent molecules is that one molecule is completely separate from another molecule. They don't have anything to do with each other. So the only force that will exist between them is going to be weak intermolecular forces. And in this case, it's going to be van der Waals forces. So the words that you're going to write is that the first thing is it's a simple molecular lattice. With weak van der Waals forces. Clear? Remember, ionic, make sure you know the reasons why ionic substances have high melting points, and make sure you know what the reasons. Remember, there could be other forces as well, but in this case, it's just van der Waals forces. Is that clear?
Yes.
Yes.
So write an equation for, again, SiCl4 with water. We've already done that frequently. Okay, it's going to hydrolyze. It will form SiOH4 or SiO2 and release HCl. Okay, that's the reaction. It's going to be a vigorous reaction. What is the pH of the solution formed when each of the following compounds is dissolved? NaCl, nothing happens. Nothing happens. It only dissolves so that the pH is 7. PCl5, when you react it with water, there's going to be strong hydrolysis. HCl would be formed and H3PO4. Two highly acidic solutions would be formed, and the pH would be strongly acidic. Let's call that 2. Okay, that's given over here as well. PCl5 reacting with water would form these two acids. So, and it would be a vigorous reaction. You'll see fumes of HCl that would be formed. Then the dimerization of aluminum chloride is saying that at 1100 kelvins, the vapor, he's talking about aluminum chloride. So the vapor has an MR of 133.5. So that would mean 1 Al and 3 Cls. But at 451 kelvins, the MR is 267. That means it has doubled. So that means it has formed a dimer, which is that two molecules have joined together to form Al2Cl6. And he's asking for the dot and cross diagram for that. So that exists at the higher temperature, which is this one. So that is simply Al with 3 Cls. And Al will form single bonds with each one of the Cls. These are the remaining 6 electrons of Cl. And अच्छा वो से form कर लिए, and its octet is not complete. It still needs 2 electrons, which is why it can form dative bonds. Aluminium does not have 8 electrons even after making 3 bonds. So draw a displayed formula of the aluminum chloride that exists at the lower temperature, Al2Cl6. So what happens is, and now he's asking for the displayed formula. So you don't have to draw the dot and cross diagram, you just have to. So that's an AlCl3 molecule, and here's your other AlCl3. And remember, aluminium needs 2 electrons. Its outer shell is not complete. So it would form a dative bond by borrowing or sharing lone pairs from Cl. So 2 of the bonds, so you have to clearly label the different types of bonds. So you're going to show them, or you're going to tell them that that's a normal covalent bond. While this one is your coordinate bond or your dative covalent bond. Okay, you clear it? Remember this example. This comes very frequently in exams. AlCl3 forming a dimer. Okay, is that clear?
Yes, sir.
Yes.
अच्छा, ये आप लोग ही बता दो. An element that has a molecule that contains only one atom. So who contains one atom? Like which one is monatomic out of all of these elements?
Cl. Nitrogen.
कौन से elements होते हैं that don't like to bond with anything?
The group helium and
Noble gases, right? So it's, I mean, you can go with neon, right? उसने कुछ कहा तो नहीं है from the element shown, any element, so it could be anyone, helium, neon, or argon. Helium and neon are better answers. An element that has a molecule which contains only 4 atoms. We just did that. Which molecule contains 4 atoms? कौन सा molecule is the formula that's 4 atoms? It contains 4 atoms. Like we're talking about the element.
Phosphorus.
Yes, exactly. So that is phosphorus. Phosphorus has 4 atoms. So the molecule of phosphorus is P4. That's an element that has the largest atomic radius. Now this question, this is about atomic radius. So first thing, you upar wale, the top ones, are they big or small? Which one is big, the top ones or the bottom ones?
bottom.
The bottom ones.
Okay, so
Bottom.
one thing is the ones right at the bottom. Okay, कहीं पे भी किसी भी group में ना, the ones at the bottom, they're bigger because they have more shells, right? अच्छा, अब आ जाता है left one or right one. Which one is bigger? What happens to, so we're basically looking for the bottom ones, right? The bigger atoms, ye sare. So second question is, which one is there? The left one or the right one? What happens to the atomic radius across the period? What happens to it? Does it become bigger or smaller?
Smaller.
Okay, so across the period, this side has smaller atoms and this side has bigger atoms. So by this logic, K is going to have the largest, in Saro mein, K is going to have the largest atomic radius. Why does the radius यहाँ पे लिखा है, उसकी reasons भी होंगी. Okay, if I zoom in on this. Achha, so why does the radius, atomic radius, not the ionic radius, but the atomic radius, why does it decrease to the right? Because you've got more protons. Agar sodium यहाँ पे होगा, that's 11 protons. On the other side, you have chlorine, which has 17 protons. They have the same number of shells, exactly same number of shells. So they've got the same number of shells, but because you have greater protons, there's going to be more attraction for electrons. But a bromine gets 35 protons, and potassium just has 9. I mean, that's double the proton, so there's double the attraction. So the atom bromine would be much smaller compared to potassium. So potassium is the right answer. Okay, clear hai ye?
Yes, sir.
Of an element that is a liquid at room temperature and pressure. So which element is, I mean, just make a wild guess. Which element is a liquid? And remember, when they ask you about this question, remember you've only studied period 3 and group 2 and group 17. So it's better to just focus on what you have studied. Like group 1 is not in your course. Isme bata do, which one is a liquid? Like group 17, which one is a liquid?
Bromine.
Bromine.
Okay, so Br2 is a,
Bromine.
okay. As a Br2 is a liquid. The element that has the high, abhi wo period 3 ka aa gaya, which has the highest. So it's the period that you have studied. It's this one. Jinko maine line karo. So in Salome, which one has the highest melting point? Okay, this पे सबसे highest किसका है? That's silicon, right? Because it's got a giant covalent structure. Silicon has the highest melting point and boiling point. Clear है सारों को?
Yes. Yes.
Yeah.
So next one, the element Na2Ar that forms the largest anion. ठीक है? फिर से top one or bottom one? That's probably going to be the bottom one, right? Because the largest anion, the largest atoms or ions would be the ones at the bottom. Now, anions are formed by these elements. I mean, the anion is a negative ion, right? So we're dealing with negative ions. So we're dealing with negative ions. Now the issue is, which one has the biggest negative ion out of ये anionic radiuses था, ठीक है, across the period. Remember that the anion is always bigger than the atomic radius. Why? Because the anion has extra electrons. It's gaining electrons. It's got extra electrons. If it's got extra electrons, it's going to be bigger in size compared to the atom. So anions are bigger in size, but when you move across the period, you have more protons. So obviously, yes, मैं थोड़ा detail में भी कर लूँ कि anions का अगर हम करें ना, if I talk about phosphorus, and phosphorus is 3-. If I talk about sulfur, right next to it, that's 2-. And then I have Cl, which is 1-. Anions are all isoelectronic. What that means is, कि phosphorus के पास 15 electrons होने चाहिए थे, but now it has 18 electrons. Sulfur atomic number is 16. It should have 16 electrons, but now it has 18 electrons. Chlorine has a proton number of 17, should have 17 electrons, but at the moment it's got 18 electrons. So they're all isoelectronic, which means that they have exactly the same number of electrons. Lekin phosphorus only has 15 protons. Sulfur has 16 protons. And chlorine has 17 protons. So who's going to attract electrons more strongly? So chlorine के case में ना, ठीक है, तो chlorine के case में ना, there's going to be more attraction. So it's going to be smaller in size. ठीक है, because it's got 17, so there's more attraction. When you move to the right, you're going to have. So you're going to have more attraction. So anions, their size decreases when you move to the right because they all have the same number of electrons, but obviously because you have greater protons, the attraction increases. So it's going to be smaller in size. So अगर इस question पे आओगे ना, he's talking about the largest anion. So I'm talking about these ones. This one, Br forms -1, Se forms -2, and As3 would probably form -3. So the biggest one would probably be As3, because right की तरफ the size would decrease. नहीं, sorry, इसकी तो वो बात नहीं कर रहा था, period C की बात कर रहा था. He wasn't talking about, I mean, part number 6, इसको तो side पे गया. I said he was coming back to this. Part number 6 was actually about period number 3. So he was talking about the same ones: phosphorus, sulfur, and Cl-1. So we just discussed that phosphorus is going to be the biggest one. Okay, is that clear? You clear of phosphorus?
Yes, sir.
Yes.
Yep.
Okay, use the element shown to answer the following. Give the formula of 2 acidic oxides. Remember, non-metal oxides are acidic oxides. So you're not going to look at the whole periodic table. You're only going to discuss. I mean, the first thing is you're going to discuss those oxides that's in your course. So these, बल्कि यहाँ नीचे लिखा हुआ है acidic oxides or basic oxides यहाँ पे. So which ones are acidic? Phosphorus oxides and sulfur oxides are acidic. SiO2 is weakly acidic. So we're going to go with phosphorus and sulfur oxides. So P4O10 and SO2 or SO3. This one,
It says by the same element.
that's a formula of 2 acids, so that's even easy. You can either go for P4O10 and P4O6, क्योंकि same element P4O10 P4O6, right? And SO2 or SO3. So you can also, the other option would have been SO2 and SO3. So give the formula of an oxide that is amphoteric. So again, it's this one. Aluminium oxide is amphoteric. It's capable of reacting with HCl and also with NaOH. So this one is Al2O3. Identify an element whose oxide dissolves readily in water to give a strongly alkaline. So an oxide dissolving in water to form an alkaline, strongly alkaline solution. So that one is a basic oxide. It's probably going to be this one. So upar wo reaction bhi given hai, because I think the first two are strongly basic. Not this one. This one is not strongly basic because it's not very soluble. But the first one is very soluble. So that is strongly alkaline. So you just have to name the element sodium. Identify an element whose chloride dissolves in water to give a neutral solution. So it's again about chlorides, and only the first one, NaCl, is the only one that gives a neutral solution with pH 7. उसके बाद hydrolysis जो है ना वो strong होता जाता है. So that one is NaCl as well. And identify an element that reacts with water to give a solution that can behave as an oxidizing agent. So, and that can behave as an oxidizing agent. So, or likha reacts with water. So first thing, what is an oxidizing agent? An oxidizing agent is what? It loses electrons or gains electrons? खुद क्या होता है? Reduce होता है या what happens to it?
It gets reduced.
It gets reduced.
So it gains electrons, right?
Yeah.
So we're basically talking about group 17 over here. Okay, मैं group 17 निकाल लेता हूँ वैसे. इससे नीचे होगा. Remember, group 17 elements are very good oxidizing. They've got good oxidizing ability because they like to gain electrons. And so what happens is if you have Cl2, it will try to gain electrons. If you have Br2, that would also try to gain electrons. I2, the top ones are very electronegative, so they really like to gain electrons. The bottom ones, जो iodine का atom है ना, that's very big. It doesn't really like to. मतलब iodine का atom अगर मैं show करूँ ना, it's got 53 electrons. It's got 53 electrons. So it already has so many electrons that it no longer is interested in gaining more electrons because the nucleus is too shielded. तो बाहर से ना एक और electron gain करना, that's kind of difficult for it. So down the group, they become weaker oxidizing agents. They're less easily reduced. They lose the tendency to gain electrons. Smaller atoms are able to do that. So we're going to go with Cl2 because the question had also said that it also reacts with water. So Cl2 also reacts with water. Cl2 has the ability to react with water as well. And obviously it's a good. So Cl2 would be good. That would be sufficient.
So HCl is an oxidizing agent?
No, not HCl. HClO is a very good oxidizing agent.
Oh, okay.
ठीक है, क्योंकि यहाँ पे Cl is actually +1, right? And this is Cl actually wants to be -1. I mean, this is capable of losing oxygen.
All right.
ठीक है. और ज़्यादा याद रखना कि oxidizing, when you think of oxidizing agents, think of group 17 elements, because they like to get reduced. That's why. ठीक है.
Okay.
So the answer to that would be Cl2 and write an equation for the reaction of aluminum with oxygen to form. I mean, that's easy. But her equation balance kar dena, theek hai. It just forms Al2O3. That's it. Why is there a high melting and boiling point of Al2O3? Why? Because it's an ionic compound. So it's going to be yoga. Okay, it's going to be. It forms a giant ionic. It's the same explanation. One point would be for the giant ionic lattice, and there's strong attraction between oppositely charged ions. Between what you can write as cations and anions. So more energy is needed. Okay.
Sir,
Yes.
in balancing the equations, when can we use fractions? Can we use it in question A?
You can use that. Usually, as long as it's, I mean, there's no specific rule for that basically, but the preferred way is to have a whole number equation. That's the preferred way. But you can, if it's divided by 2, then that's fine. Like over here, if you have,
In some cases, you should put the divided by 2, no?
it's always better to have. There's no specific rule for that basically. It's better to actually go with whole numbers because I mean, the main idea is whole numbers are less confusing. Like even if you want to do ratios, dealing with fractions kind of like if you have a moles question, dealing with fractions would be more difficult. But 1 by 2 is kind of, or divided by 2 is kind of acceptable. I think that's balanced, right? But
Yeah, it is.
even this would probably
No,
not.
no, it's 2A.
It's sorry, just a second.
It's 2A.
2L and 3 by, yeah. Ajay, so if one of them has divided by 2, then that's kind of fine. But even if you can avoid that, that would be even better if you just go with 4Al and 3O2 and 2Al2O3. Okay.
So I did a question in a past paper and it asked for fractions.
These specifically for fractions. They're
No,
not
but it didn't ask, like, you
gonna,
just had to write fractions.
they're not going to be very specific about that.
Oh, okay.
I see a low boiling point of SO3. Again, it's simple answers, simple molecular. And I'll just so it's simple molecular, and it's also going to have van der Waals forces, weak van der Waals forces. So one molecule and the other molecule, the dipoles are canceling out. So one molecule has nothing to do with the other molecule. So they would have just weak van der Waals forces, temporary dipole induced dipoles, which would be easy to break. Not a lot of energy is needed. And the melting point of SiO2 is much higher than that of P4O10. So what's the reason for that? Because SiO2 is a giant covalent structure, or a giant, or a macromolecular structure. The simple word would be macromolecular. One second. Let's just okay. This is going to be macromolecular. And this over here is going to be simple molecular. As a macromolecular, when you melt them, you're breaking strong covalent bonds. Simple molecular, when you melt them or change state, you're overcoming or breaking the weak van der Waals forces or intermolecular forces. So, and you're breaking many covalent bonds in a giant covalent structure. यहाँ पे बना हुआ भी होगा कि although we don't have कहाँ गया हमारा SI? SiO2 would be something like this. Silicon is similar. SiO2 will have oxidants in it as well. So it's you're breaking covalent bonds and you're breaking many of them. So इनमें बस बता देना कि large energy is needed, large amounts of energy needed, or more energy needed, or यहाँ पे there's going to be less energy needed. So remember, you have mainly you have three types of structures. You've got metallic, you've got ionic, and you've got covalent. Covalent के अंदर there's another one which is macromolecular or giant covalent. अच्छा वही oxide वाला suitable oxide which makes an alkaline solution, that's sodium oxide. In each case, write an equation. So we're going to write an equation. It's going to form 2NaOH. And it forms an acidic solution. So sulfur trioxide कर लेते हैं. If you react it with water, it would form H2SO4. ठीक है? And you have lots of options available कि वो oxides. Even this was making a weakly alkaline solution, magnesium oxide. ये बीच वाले जो दो हैं, they don't dissolve. Phosphorus oxides makes phosphoric acid and so on. So we wrote two of them. अच्छा फिर next question is कि you've got
Sir,
हाँ जी
real quick, oxidizing means gains electron, right?
need oxidizing agent or what? If something
Yeah,
is,
I can't remember. So
huh?
I don't remember, so I'm asking. I don't know.
If something is an oxidizing agent or an oxidant, that is getting reduced. So it's gaining electrons. Like
Okay, so reduce means gain electrons, basically. Right?
कौन सा? हाँ, reduce.
Reduce.
What you can do is you can just remember oil rig, which means oxidation is loss of electrons, reduction is gain of electrons. And,
Yeah, okay.
and the names are opposite. Like if something is an oxidizing agent, it's basically undergoing reduction.
Yeah, okay.
If something is the reducing agent or the reductant, then it is undergoing oxidation. I said dot and cross diagram. This is O-level stuff. क्या होता था? Magnesium had 12 electrons, so it's 2, 8, and 2. So वो जो बाहर वाले outer 2 electrons, they're going to be lost. So it's going to form a +2 ion. And oxygen, oxygen will be 2 and 6. And it would gain those 2 electrons, it would form -2. So that's about it. And remember, there are a couple of ways of drawing this structure. There's a Lewis structure as well. The only difference is they don't draw the circle. I mean, the electrons are still there, but not with the circle. But it doesn't make a difference. Don't get confused in the marking scheme. Whether they draw the circle or they don't draw the circle, it's the same thing. And oxide that reacts with water to form a strongly, that's sodium. Okay, we've done that. An oxide that is insoluble in water. That is, you've got two oxides. You've got aluminum oxide and you've got SiO2 as well. Okay, remember there are actually two oxides. They have no reaction with water. They don't dissolve. SiO2 is sand basically. An oxide that reacts vigorously to form a strongly acidic solution. I mean, you can go with sulfur trioxide. An oxide that has a simple molecular structure. You've got lots of them. I mean, all molecules, SO3, SO2, P4O10, P4O6, they're all simple molecular. फिर है कि an oxide that reacts that acts as a food preservative. That is sulfur dioxide. Okay, that's a property of sulfur dioxide. यहाँ पे अगर उस पे जाओ ना, नाइट्रोजन सल्फर का भी टॉपिक है इसमें. If you go over here, कहीं ना कहीं लिखा होगा, एक सेकंड, सल्फर के यूजेस। पता नहीं, SO2 Here, O-levels का question है. Let me just, if it's not written, I'll just add it. कि चलो extra points पे लिख देते हैं कि O-levels में you have studied that SO2 acts as a food preservative. And it also acts as a, because it's a very good reducing agent. And it bleaches wood pulp for making paper. चलो ठीक है, ये इसका हो गया. और अच्छा, we're going to try and do group 17, ठीक है, tomorrow then. ये हमने काफी कर लिया इसके questions. Just remember most of it, go through this worksheet, and just remember most of the questions are going to be kind of very similar. बस ये एक page है, 1.5 pages है, about period 3 that's got to be memorized, ठीक है. ये जो इसमें points लिखे हैं, करना ये इसको print करके अपने साथ रख लो. Well, over time, you'll memorize a lot of stuff on its own when you're doing practicing past papers. मतलब जो PDF मैंने send की थी, just print it out. Make sure you जो extra points लिखे हो ना side पे, just make sure you include that बीच में आप comments डाल के ना, and try and memorize all of this, ठीक है. चलो ठीक है, कल फिर उस पे करते हैं बात.
Okay, sir.
Group 17.
Okay, sir. Assalamualaikum.
Okay, sir. Allah Hafiz.
Allah Hafiz.